Hello everyone. In this video, I'm going to discuss about a linked list. So first we'll see why linked list, what is linked list, everything I'm going to explain. So I'm going to declare one array. If we declare array, this is array of 5 elements. For 5 elements, it allocate the memory. Just to assume all these are memory locations. Okay. And A of 5 means continuously it allocate memory for 5 elements. The memory name is A under single name. So we can store 5 elements. Fine. So again I am going to allocate memory for X, Y, Z. Okay. And somewhere it allocates. Just to assume for X it allocated memory here, Y allocated memory here, Z allocated memory here. Not continuously because these are normal integers, not array. This is one array. So for array it allocates continuous memory. Fine. If at all I want to store one more element, like a sixth element I want to store. So I have to increase the array size. So it is not possible. See, already the next memory is assigned to X. Here also, before this memory also assigned to Y. So you cannot extend this memory. So you cannot increase the size of the array. And one more it is, if at all I allocated memory for 5 elements, I am going to store only 3 elements. Then the remaining memory will be wasted. This is the basic disadvantage of array. So we'll see one more example. For example, I'm going to allocate memory for one element. So, and assigned one value 10. And again, if I allocate memory for one element, somewhere it allocates. Wherever the memory is free, just you assume these memory locations occupied with other elements. Then here, if at all it is free, then allocate the memory. Here it is free, allocate the memory. So again, I want to store one more element. Again, it allocate the memory. So like this, so n number of elements you can store. So there is no continuous memory. Somewhere, wherever the memory is free, in that location, see, it is allocating memory for you. In that location, we are assigning the value. Fine. But the problem is how to access all these elements. In this array, all the elements are stored under single name. With the help of index, easily we can access the elements. But here, wherever the memory is free, randomly it assigns the value, right? So, how to access this memory means all these are like a list of elements only. All these are list of elements. Then how to access means every element, if at all if we store the address of this element, with the help of address, easily you can go there and you can access the element. Again same, if at all if we store this element address here, so then with the help of address you can access 30, and after 30 we have to store the address of 40. Then with the help of address you can access the 40. So this is the concept of linked list. All these are list of elements only, same list. So we have to connect with the help of address. With the help of address, you can access the next element. Okay. So here the memory is not fixed. So runtime, you can increase or decrease the size. So that is the advantage of linked list. Here we are not wasting the memory. See, after 4 elements, if at all again I want to insert the element, somewhere it allocate the memory. After 40, I assigned 5. So for after 40, you have to store the address of 5. So with the help of this address, I can access the 5. Again, next, after 5 also, if at all you want to assign one more value, somewhere it allocate the memory, you can assign the value simply with the help of address, you can access that element. That is the advantage. Here we are not wasting the memory. So this is the basic difference between array and linked list. So linked list means collection of nodes. Collection of nodes. What is node means? So for nodes, it won't assign continuous memory. If continuous memory is free, it depends on the compiler. Continuously memory is free, it allocate the memory. Otherwise, somewhere it allocate the memory. So using the address, you can access the next element. That is the concept of linked list. So linked list means collection of nodes. Node means collection of data and address. Just listen. This is two parts in node. So one is data and the another one is the address of the next node. And the data part means not only one element. Most of the people will think data means only one value we have to store. No, you can store n number of elements. If at all you want to store one integer, one float value and one character, you can store. And then in next node also one character, one float value and integer and the address of the next node. Like this we have to store. Data part means not only one value, more than one value also you can store. For example, you want to store your details, one student details, student name, student roll number, student marks, then address of the next student details, again second student name, second student roll number and marks, and address of the next student details. Like this is the one advantage of the linked list. Like this we have to assign the values. All these are the values we are going to store, and address of the next node also we have to store in the node. So basically node means data and address. So data and address. In data part we can store the data, any kind of data you can store, more than one value also you can store. But in address part only one address, only the address of the next node we have to store. I'm discussing about the single linked list. So only one address of the next node we have to store here. Okay. And next, this is the node. Okay, fine. Data and address we can store in this node. How to allocate memory for node? So if at all you are storing only one integer, so I'm going to store value 10. 10 is the integer, so I can declare one variable int x. For x it allocate the memory, 10 will be assigned to x. Fine. If at all I want to store similar values like a 10, 20, 30, you can declare one array. So continuously it allocate memory for array under single name. You can store all these three values. Fine. But here, how to allocate memory for node? What you are storing in node? One is data and another part is address. In data part, I'm going to store one integer. You can store any type of value, but in simple example, I'm going to explain only one value I'm going to take. We can take more than one also, but in this example, I'm going to store only one integer. So this is integer and here I have to store the address. Okay. So one integer and another one is the address we are going to store. These, if at all, these two are integers or these two are floats, I can like declare one array. But these two are different values. So integer is different. Address means one pointer variable we have to declare. Okay. So these two are not homogeneous elements, heterogeneous elements, different types of elements. But under single name, I want to allocate the memory. This is completely one node. Under single name, I want to store this number and address. So not homogeneous means easily I can declare one array. Under single name I can store these two values, but these two are not similar. These two are heterogeneous elements, means different elements. So the concept is structure means collection of heterogeneous elements. So if at all you want to allocate memory for different values under single name, you have to declare one structure. We'll see how to declare the structure. Okay, I'm going to declare one structure. Keyword is struct and structure name. Any name you can take. I've taken node is my structure name. What you are going to store in this node? One is integer. Okay, I'm going to declare int roll number. I want to store roll number of students. So int roll number. So I'm going to store only roll number. The remaining details also, if at all you want, you can store. It becomes very lengthy. So simple example I'm taking. So int roll number. The next part we have to store the address of the next node. Means pointer variable we have to declare. The pointer variable name is next. So before finishing this one, first I'll tell you one example. If at all we want to store, see, this is one example. I just declared one x. So for x it allocates some memory. Just you assume the address is 500. So for x, I assigned one value, that is 10. This is variable name, variable value. This is variable address. If at all you want to store this address, then you have to declare one pointer variable. I am going to declare one pointer variable p. So p equals to address of x. Now address of x will be assigned to p. Fine. X is integer, so p also you have to take integer. In integer pointer, you can store the address of integer variable. For example, float x. If x is float, then this becomes wrong. Only in integer pointer only you can store integer value address. Okay, I hope you got this point. Now, come back to this one. Now, in next variable, in next pointer, I wanted to store the address of, we have to store the address of the next node. What is the type of node? If node is integer, I can declare int next. But what is type of this node? Node is the type of structure, heterogeneous elements, collection of different elements. So node is the type of structure. So next is also type of structure, struct node next. If you understand the basics, the remaining easily we can allocate, means easily we can store the addresses, easily we can create inside the elements also. Basics are important. Struct node next. So only these two members I am going to store in this node. Now this is one structure, these two are the members. So if at all I want to assign 10 to roll number, then roll number equals to 10. So this is wrong. Directly you cannot access the structure member. With the help of structure variable only you have to access structure members. So I'm going to declare structure members. Here we are allocating memory, like dynamically we are allocating the memory. So pointer variable, we declare some pointer variable. I'm going to declare one pointer variable, that is nn. Okay, nn is one structure variable, and one more it is like first. So these two are like structure variables. Okay, fine. Now if at all you want to access this roll number, first of all you have to allocate memory for nn, then only you can store roll number and next. Okay, nn is one variable. I just first will allocate memory for nn. Okay, for nn I want to allocate the memory. So dynamically how to allocate memory? Using malloc function, calloc function, realloc. Realloc means resize. So using malloc function I am going to allocate memory for nn. So nn equals to how much memory we have to allocate for node? In node we have to store roll number and next. For one integer and one pointer variable, we have to allocate the memory. If two members are there, you have to allocate memory for two members. If three members are there, we have to allocate memory for three members. It depends on the size of the structure. If the structure size is 10 bytes, we have to allocate memory 10 bytes. If structure size is 20 bytes, we have to allocate 20 bytes of memory. So, size of struct node. So using malloc function. So struct node asterisk malloc size of struct node. Whatever the size, that much memory it will allocate using malloc is a function name. And the first byte address will be assigned to nn. So size of struct node. What is the size of the structure? One is integer 4 bytes, one is pointer variable 4 bytes. Total, it allocates 8 bytes of memory. For example, the first byte address is 200, then that will be assigned to nn. This is nn, variable name. Now, with the help of this variable, you can access the member. For two members, it allocated memory for two members. What is the first member? This is a roll number and this is the next. Then how to access members? With the help of variable. Now nn is pointer variable, so using arrow you can access the member. Nn of roll number, nn of next. Okay. Now nn of roll number. Nn of roll number is one integer, so I am going to assign one integer. Nn of roll number is 15. Fine. 15 will be assigned. Now in NN of next, what you have to store? Address of the next node. Now there is no next node, simply assign null. Okay, like this, we have to create one node. You have to allocate memory for node and the node name is NN. Like this, you can access the members. Now again, I want to allocate memory for another node. See, for example, like PTR, declare another variable PTR. PTR equals to struct node asterisk malloc size of struct node. So again, it allocates memory for node. Size of struct node. Size of the structure is 8 bytes. It allocates 8 bytes of memory. For example, assume the address is 400. Then 400 will be assigned to PTR. Now this node name is PTR. This node name is new node. Now how to add these two nodes? How to access it? In the place of null, we have to store the address of this node. Address of this node is 400. In place of null, I have to store 400. So 400 is assigned to PTR. Now what is PTR? 400. Okay. Now first of all, we'll assign the roll number. PTR, how to access this member? PTR of roll number. Okay, PTR of roll number is 20. 20 will be assigned here. There is no next node. So PTR of next equals to null. Okay, PTR of next is null. Now we have to combine these two nodes. Then have to combine in place of null. I have to store 400. Where is 400? How to access this 400? PTR is 400. PTR of roll number and PTR of next is null. PTR of roll number is 20. What is PTR? 400. So in place of null, how to access this memory? NN of next. Okay. In place of NN of next, we have to assign 400. 400 means PTR. So NN of next is PTR means in place of null, it will assign 400. Like this, you can access the next element. For example, if at all you want to access the 20. 20 means PTR of roll number. NN of next is 400. See, NN of next is 400. 400 of roll number is 20. NN of next of roll number. Like this, you can access the next element also. These are the basics. In next video, I'm going to explain creation of linked list and how to insert the elements, how to remove the elements and all. Thanks for watching.